Hello viewers, this video is on application of simple linear regression analysis where we use two variable linear regression model to estimate a consumption function. Question: in a survey, weekly family consumption expenditure Y and weekly family income X of a village are observed as the values of Y are this and the values of X are these. Question 1. Estimate the consumption function of the family Y is equal to beta naught plus beta 1 X plus U. Number 2. Find R square. Number 3. Test the significance of the parameters at 5% level of significance. Question 4. Interpret the results. Solution: calculation table where we put the values of Y and values of X like this. We sum up the values of Y, that is summation Ui is equal to 110 and summation Xi is equal to 1700. Next we multiply Yi with the Xi and we get the summation Xi Yi is 208150. Next we calculate the square of Xi's and summation Xi square are 325400 and we calculate square of Yi and we get the summation of Yi square as 134000. Now the mean of Y is Y bar is equal to summation Y by divided by n, and mean of X, that is X bar, is equal to summation Xi divided by n, and we got Y bar as 111 and X bar as 170. Estimation of beta naught and beta 1 cap are: we know that the estimator of beta 1 cap, or we know that the OLS estimator of beta 1 cap is equal to n into summation Yi Xi minus summation Yi Xi divided by n into summation Xi square minus summation Xi whole square. After putting the values from this table, we get beta cap 1 is equal to 0.534. Therefore, beta naught cap is equal to Y bar minus beta 1 cap into X bar, that is equal to 111 minus 0.534 into 170, and that is equal to 20.22. So the estimated consumption function is Y cap is equal to 20.22 plus 0.534x. Estimation of variances. Summation of small xi square is equal to summation of capital Xi square minus summation xi divided by n. So that is equal to 36400. Next, the summation small yi square is equal to summation capital I square minus summation capital Y I divided by n, and we found the value as 10790. Next, summation small ei square, that is residual sum of squares, is equal to summation small yi square minus beta 1 cap into summation small xi square, is equal to found 410.32. Here summation ei square is the residual sum of squares and summation small yi square is the total sum of squares, and beta naught cap into summation xi square is the estimated sum of squares. Therefore, the variance of the error term u is sigma u square is equal to summation ei square divided by n minus 2, and we got the value as 51.29. Now, variance of beta 1 cap is equal to sigma square u, that is variance of error term u divided by summation small I square, and that is we found as 0.0014. Therefore, standard error of beta 1 cap is equal to square root of variance of beta 1 cap, and that is equal to 0.037. Next, variance of beta naught cap is equal to variance of u into summation capital Xi divided by n into summation small xi square, and after putting the values we get the value, or we get the variance of beta naught cap as 45.85. Therefore, standard error of beta naught cap is equal to square root of variance of beta naught cap, and is found as 6.77. Now, capital R square, that is coefficient of determination, is equal to beta 1 cap square into summation xi square divided by summation yi square, or that is equal to 1 minus summation ei square divided by summation yi square, and after putting the values we get 0.962. Therefore, 96.2% of the variations are explained by the variable x. It states higher level of goodness of it, because 96.2% of the variations are explained by the variable x. Hypothesis testing. Since sample is small, here n is equal to 10, which is less than 30, so we apply t-test. Suppose the null hypothesis regarding beta 1 is equal to 0, and alternatively beta 1 is not equal to 0. Here t star, that is t value of beta 1 cap, is equal to beta 1 cap divided by standard error of beta 1 cap, and here the value is 14.43, while the table value of t at 5% of level of significance with 8 degree of freedom is 2.31. Since the value of 14.43 lies outside the acceptance region, the hypothesis of no relation between y and x is rejected. Therefore, beta 1 cap is statistically significant. Similarly, null hypothesis for beta naught cap is equal to 0, or alternatively beta naught is not equal to 0. Here the t value for beta naught cap is equal to beta naught cap divided by standard error of beta naught cap, and is found 2.99, but the table value is 2.31. Since the calculated value of beta naught cap, that is calculated t value of beta naught cap, is greater than the tabulation or tabulated t value of t at 5% of level of significance. So, we reject the null hypothesis and we accept that beta naught coefficient is also statistically significant. Now, interpretation of the result or reporting the result. Here we have found that the estimated line as y cap is equal to 20.22 plus 0.534x, where standard errors are 6.77 and 0.037 and the R square value is 0.962. So, the value of R square of 0.962 shows that about 96.2% of the variation in the consumption expenditure is explained by income. The estimated coefficient beta naught cap and beta 1 cap are statistically significant at 5% level of significance. In general, consumption expenditure of a family depends on the level of income of the family. The estimated consumption equation shows that the autonomous consumption is rupees 20.22, which indicates the average consumption expenditure of the family at zero level of income. The coefficient of the variables x, that is values of beta 1 cap, is equal to 0.534, which measures the slope of the consumption expenditure line. It shows that an increase in the level of income by rupees 100, the estimated consumption expenditure of the family will increase in average by rupees 53.4. It measures the marginal propensity to consume, or here MPC is equal to 0.534. Well, so this is the application of simple linear regression analysis for the estimation of a consumption function. Thank you.